Hey TCMS, this is Mrs. Martin, and welcome back from spring break. This is our first set of notes since we went on that small break from school. I hope that you were able to enjoy it. It was restful. I hope you had a chance to catch up on work with all of your classes. And now we're back to it. We left off last time doing tree diagrams, and based off of the work that I received from both my period 1 and my period 4 classes, you guys really got a good understanding of how to create tree diagrams. If you haven't done so already, please check your grade for that assignment. If you got a 10 out of 10, that means your tree diagram was looking good, everything was accurate and organized and set up in a way that if you were to produce that on the next quiz, then you would get full credit for that. If you did not receive full credit, that means I probably left you a note on your grade on how to fix it. Please, please take this opportunity to resubmit your work so that I can give you points for that. It's a great chance for you to learn from any mistakes you might have done. It might have been something really small that I'd like you to fix so that you don't make that mistake again. And then you'll be all ready and prepared for when the quiz does come. So again, I appreciate all of the images that you guys were able to upload onto Schoology. I liked that some of you were able to work with Google Docs and submit your assignments. And if you did not get full credit, please resubmit. This whole process is just that you can learn the material, and since we're not together and I can't help you make those corrections in person, I want to make sure that you're getting the corrections online and you're making those corrections and you're earning your full credit. So again, if you didn't get full points, you still can. Just make sure you resubmit. Okay, and to kind of continue where we left off from tree diagrams, a lot of you became really efficient at finding a new method of counting up all these combinations. Most of you were using multiplication, and we're going to talk about that today. And that's the whole point of today's note, is to find more efficient ways of determining combinations. Because, you know, trees are nice, they're detailed. If I wanted to know what combinations existed, tree diagrams are nice for that. You can really kind of get an idea of what options you have. But if I'm not concerned about what combinations exist, and I'm only concerned with how many combinations exist, maybe making tree diagrams isn't very efficient. You know, they take a long time. If I have a lot of categories happening, then the tree can start getting pretty large and messy and hard to read. So having a more efficient way of determining combinations would be nice. So before I get started, I want to make sure that I give this disclaimer, okay? Terminology in statistics, specifically combinatorics, is often not standard. So what I mean by that is lots of different courses might use different vocabulary for these principles that I'm going to mention today. So in the future, you know, when you guys are off in college and possibly taking a stats or a combinatorics course, it might be possible that you hear a different name for these principles, but they all work the same. So I just wanted to make that disclaimer. So again, terminology is not standard. Okay, well, they use many different names. Multiplication, which is what we're going to start with, our multiplication principle of counting, or our multiplication principle of counting, which we're going to start with, is often referred to as the fundamental principle of counting. So, you know, just some things to keep in mind as we work through these. You may see them referred to differently in the future. As a matter of fact, I think Alex might refer to it as the fundamental principle of counting instead of the multiplication principle of counting. I'm not 100% sure. I can't remember from last year, but if that's the case, they mean the same thing. Okay, so just some things to keep in mind. So let's get started. Okay, we're going to cover two principles of counting today. and then you'll have some an associated assignment on Schoology, so keep your eyes open for that. And a lot of you have mentioned in your discussion that you like to come back to these videos and pause and rewind, and some of you actually accidentally sent me a picture of your notes instead of your assignment before we left on spring break. And even though it wasn't the assignment I was looking for, I was glad to see that some of you are taking notes at home, so thank you for that. So yeah, let's get started. So here's our first one, okay? And again, I mentioned that we are starting with the multiplication principle of counting. Okay, and many of you guys intuitively understood how the multiplication principle of counting works. Okay, so pretty much what it is we are counting all the outcomes from each task. What they call them tasks or categories, okay? So in your textbook, they often refer to them as tasks or categories. And then once you figure out how many tasks or categories you have and what options you have within those categories, then we just multiply them together. Okay, and a lot of you figured this out even as far back as the yogurt problem. Okay, so let's consider an example together. Okay, so here's my example. All right, so let's say I'm trying to pick out an outfit for another day of work from home. Okay, so I'm trying to pick out my outfit for today, and I have some options. Okay, for my outfit, I have an option of 3 shirts. This is not a true story. I have more than 3 shirts. But I have, for the sake of the story, I've got 3 shirts. I've got 2 pairs of pants that I can choose from. And I really like shoes. So let's say I've got 7 shoe choices. All right. If these are the options that I have at home for picking out my outfit, a question I might have is how many, let's say I didn't want to wear the same combination every time, how many outfit combos are possible? Now, these options aren't incredibly large options. These numbers, not any single one of these numbers are particularly big, but having 7 shoes might still be kind of a pain to draw in a tree diagram. So instead, let's use our multiplication principle. Okay, so instead of doing my tree diagram, I can just take 3, multiply it by 2, multiply it by 7, and end up with 42 different outfits that I can put together out of the clothes that I've been given. Okay, so not bad. I mean, just 3 shirts, 2 pants. I'm pretty sure the 7 shoes are what made it possible for me to have 42 different combination outfits. But still, 42 outfits, that's more than a month's worth of outfits. So regardless, multiplication principle helped us avoid creating a huge tree diagram if I didn't really need that information. Okay, one thing that might be important to note here is that in this example, things must be independent. Okay, that's important. And let's talk about independence for a second. Independence is pretty much this idea that one thing does not rely on another. Okay, so let's, for this example's sake, consider the possibility that I don't care about matching my clothes. right? So if I've got, and some of you are really, really good. I remember you in school having awesome combinations of colors in your outfits. Let's say I don't care about matching colors, you know, I don't care about color coordinating. Everything's just independent of itself. I can wear whatever I want together with whatever's given, okay? But we all know that there are some of us who, if I wear a red shirt, I might have to wear red shoes, right? And I can think of a few names, but I'm not going to say them now. But there are some of you who, you know, if I'm wearing a black hat, I might want to match those with some black jeans. Okay, so that would mean that one thing is dependent on the other. If I make one choice, it's going to affect my choice in another category. If I pick a red shirt, it might affect the choices I make in my shoes or my pants. Okay, so for these current situations, we're going to go ahead and pretend that we don't care about that and that these are independent, okay? In other words, each task or category does not depend on the other. Okay? So just some things, some vocabulary to keep in mind, and that takes care of our multiplication principle of counting. You know, the other principle of counting that we have is a little more involved, okay? And we're going to take the example of school clubs, okay? So let's talk about that. Let's start a new page here. Okay, so we've got our addition principle of counting. Okay, many of you have probably seen one of these. A Venn diagram, right? We've seen Venn diagrams, maybe in English, possibly in history when we're comparing two events. Okay, but we've seen Venn diagrams before, and we're going to use them today, and we're going to talk about school clubs. Okay, this is going to be our example. And in our clubs, we're going to go ahead and have drama, and we'll have sports club. Okay, and we all know that people that are here are in both clubs, right? We worked with Venn diagrams before, and we know that the intersection between the two bubbles is where it refers to individuals who are in both circles. Okay, so if you think about your circle of friends, right, then your circle of friends in drama versus the circle of friends in sports, there are some people who are involved with both. Okay, so let's give some names in here. We're going to pick some random names. We'll have Steve in drama. Okay, we'll put Steve in drama. We'll put Peter. Let's do some color here so that we don't lose track of what's going on. So let's have in red for drama. We'll have Steve. And we'll put Peter and Jean and Remy. Interested to see if you know where I'm getting these names from. Let's put sports in blue, and we will have Natasha in sports and Clint in sports. Okay, and finally we'll have that overachiever who is in both clubs. I don't know how they found time to be in both clubs. And that's going to be Bruce. Bruce is going to be in both clubs. And Bruce is green. How fitting. Okay, and finally, we're going to have the person who is not involved in either of these clubs. Perhaps they're involved in a club outside of school or just not drama or sports. There's plenty of clubs on our campus that are not drama and sports. We'll name this person Logan. Okay, so Logan is not in either of the clubs. Okay, so before we start, there is some notation that we should probably be aware of. Okay, we'll start off with A. We usually use the letters A and B when we're working with the addition principle of counting. And the addition principle of counting, really what we're talking about is we're talking about the groups. Okay, so A, we're going to go ahead and refer to A when we're talking about drama. We're just going to use some variables here so I don't have to write it over and over and over again. Okay, sports is blue, so we're going to put B referring to our group of sports. Okay, and finally, there's some notation that you may or may not be aware of. There is, it's not an N, but it's like an upside down cup. And this refers to the word and. Okay, I'm talking about two things here. And then there's the right side up cup, not necessarily the letter U, but like a little cup thing here. And that refers to or. Okay. And so I can use this to gather information using just notation now, because of course we're talking math. It's like another language, so we have to learn notation. So I might ask you for n of A, which really just means the number of items or people or things. Okay, the number of people in group A. And if I look over at my Venn diagram, I see very clearly that there are 4 people in group, oh, I'm sorry, not 4 people, 5 people in group A. I almost forgot about Bruce because he wasn't in the red. Okay, I've got 5 people in group A, specifically Steve, Peter, Jean, Remy, and Bruce. All right, how about the number of people in group B? Okay, think carefully. Group B, it's tempting to say 2, but we can't forget Bruce, right? Natasha, Clint, and Bruce are in group B. Okay, now it's also possible that your book will ask you for a proportion, okay, a proportion of the group. So they might use the letter P of A and ask of the group how many are in drama club. Okay, so if I count up all the people, Steve, Peter, Jean, Remy, Bruce, Natasha, Clint, and Logan, out of those 8 people, 5 are in drama club. So be very aware of what they're asking you for. If they're using the letter N, they're talking about just the number of people. But if they're using the letter P, then we're referring to a proportion of the entire group that we're talking about. Okay, and again, I'm talking about this whole group of clubs where Logan's not part of a club, but he's still part of the group that we are talking about. Okay, same thing over here with B. If I was talking about the proportion of the group B, so the proportion of the group that is in sports club, we're talking about the 3 people out of 8 that are in sports. Okay, now it is also possible that they ask you for some type of grouping of clubs. So they might ask the following question. Okay, so the number, let me stay color coordinated here, sorry. The number of A and B. So before we get to what this answer is, let's talk about what A and this symbol and B actually mean. What does it mean to say A and B? Well, really what we're talking about here is how many people are in both A and B. So pretty much how many people are in both drama, and sports. Okay, here's that and word. And there's only one person. There's only Bruce. Okay, only Bruce is involved with two clubs at the same time. Okay, and just as we mentioned before, it is possible that we use the symbol for probability instead. I'm sorry, proportion instead. The proportion of A and B. In which case we've still got 8 people. And we've got the one Bruce that is involved in both drama and sports. Okay, let's think about the next possibility because we had another symbol, right? We had the symbol or. So let's think about that one. Let's think about A or B. Okay, and what does that mean? Really, it means that you can be in either drama or sports. And how many people are in either drama or sports? Now we have to be careful here because most of us probably want to say 8 because that's everybody, but be careful because Logan's not in any sport. So instead, we've got Steve, Peter, Jean, Remy, Bruce, Natasha, and Clint. That's 7 people. Okay, 7 people involved in either drama or sports. A or B. We've got 7 out of 8 people in either drama or sports. Okay, so all this notation is just to get us to what the addition principle of counting really is. So here I've recreated our little Venn diagram so that we can discuss why it is I need to have this complicated formula anyway. I mean, you were able to count just fine earlier that there were 7 people involved in either drama or sports. So what was the big deal about having this complicated principle of counting? And the only answer I can really come up with for you is that it's often the case that you can answer the number of A and the number of B and the number of A and B, but if you're not given a Venn diagram, then answering the number of A or B becomes a little more complicated. But what's the purpose, right? Why do we need to have this complicated equation? So let's talk about it. Let's start with the people in group A, right? And let's say that my goal ultimately is to answer the question, how many people are in either drama or sports? Okay, so let's actually start with that. That's what this question, this equation even answers. How many people are in either drama or sports? Okay, so we'll start with group A. And just to kind of keep a list going, I know that I've got Steve in A, I've got Peter in A, I've got Jean in group A. This is my drama club people, right? And we cannot forget Bruce. He's easy to forget because he's in that intersection of the circles, but he's still part of drama club. That's why he's in the intersection. Okay, now let's talk about group B. In group B, our sports club, we've got Natasha and we've got Clint. And of course, we've got Bruce in the intersection. And this is where we end up with a problem. Because if I'm asking for A or B, right, I want to know about people in group A and I want to know how many people in group B. If I just add these two together, I've got an extra Bruce. Okay? Because he was counted twice. He was counted in group A and he was counted in group B. And that answers the question of why it's important to have this minus the number of A and B. Okay, that's why it's important to have that minus sign there. The number of people in both groups. because it's going to take care of the extra Bruce. I had Bruce in A. I accidentally counted Bruce again in group B. I can't just leave him out. He's part of the intersection. But what I can do is account for the extra Bruce by subtracting the intersection. And again, what I'm doing is I'm taking care of the situation of counting the intersection twice. Okay, that overlap. I just subtracted the overlap. Okay, and again, this works the same way for the probability using P. It's just then you're using fractions. I would really advise against simplifying your fractions, because then, you know, when you use this whole formula, addition and subtraction, you have to make sure your denominators are all the same. So I would just leave the denominators the same when you're working for me. Okay, for Alex, they might ask you to simplify, because I know this topic is part of your Alex pie chart. They might ask you to simplify. But when you're working on your quizzes, feel free to leave fractions unsimplified, because we want to see all of the denominators the same. Okay, so that takes care of your two principles of counting. We had two examples here. We had the example for our outfits, and we had the example for our club teams, our club memberships in drama and sports. And next time you hear from me, we will continue on with a little more complicated material with permutations and combinations. If you haven't seen exclamation points in math, then you will be very happy to know that those are coming up in our next section. Isn't that wonderful? First it was numbers, then it was letters, and now it's punctuation. So that's what you will be seeing in our next video for TCMS. I appreciate everybody who's been watching the videos and taking the time to take notes, or even just listen carefully. You know, a lot of you do really well with just listening carefully and watching the videos. Please make sure you're completing assignments. And again, if you're not getting the full points that you were aiming for, resubmit those corrections so that I can go back and grade it and give you the extra points that you lost. Okay, thank you very much for all the work you've been doing. Both my period 1 and my period 4 have been some of my best classes as far as producing assignments. I am really, really pleased with everything that you've all been doing. Keep up the good work. Continue to be safe. I know times are hard right now, especially for you all as seniors, and my heart goes out to you. But I hope that we can find some time to meet up with each other on Zoom, continue to keep in touch, and do our best to make it through the rest of the school year. Okay, so hoping to hear from you soon. This is Mrs. Martin signing off.